for today's math lesson, you're going to need your math books open to page 28. That's where we're starting today, page 28. Okay, hopefully you read on Schoology that if you are coming to the Zoom today, excuse me, you did not need to preview the video because we're going to be watching parts of it together. Yes, Brian?
I don't have my math book.
I know, honey. That's why I said you're just going to have to watch since you didn't know that you weren't going to be here today, okay?
Okay.
It'll be better than just missing the whole thing because when you come back, we're going to be moving on to drawing angles. So you can at least watch this, then we can practice it if you're feeling better tomorrow, okay?
Okay.
From length measurement. So in other words, we'll be able to tell the difference between the two. Here's what you'll need for our lesson today. Let's get started. Let's start by doing some folding of your two circles. Pause the video and fold each of your circles in half and then in half again, just like we were making a right angle template. Then open up both of your circles and trace the perpendicular lines. When you're done, come on back and we'll continue. Welcome back. Now let's label the larger circle, circle A, and the smaller one, circle B. How many angles and what kind of angles do you see at the center of each of the circles?
Okay, so let's look at circle A. Soren, watch my cursor. If I go from here to here and we have one angle, here to here's another angle, another, and another. How many total angles do we have? You muted yourself.
4.
Okay, now Brian, look over here. Here we have an angle that goes from this side to this side to this side, here, and here. So how many are in B?
4.
4. So if you notice, they're all right angles also. So keep that in mind.
There are 4 right angles at the center of each of the circles. So then, does the size of the circle impact the number or the size of the angles?
So do you think, so let's look at this. Nina, which circle is bigger?
A, the circle A.
So would this angle be bigger than this angle since the circle is bigger?
No.
No, so if you measured, Nina, from here to here, it looks like a perfect L or a square. So what is the measure of that angle?
It's a right angle.
What does it measure? What does a right angle measure?
What do you mean by that? Like,
the number, the degrees?
90 degrees.
90. Very
90
good. So if we look at this angle, Nina, what's the measure of this angle on the blue circle?
90.
Very good. So it doesn't matter whether it's a big circle or small circle, because when you're measuring the angles, you're measuring how much it's rotated, how much it's moving. So the size doesn't matter.
No, both circles, the smaller one and the larger one, have 4 right angles at their center. Interesting. And what's the measure of a right angle?
We just talked about that.
90 degrees. Let's take our dark marker now and draw an arc on circle A.
So you want to pay attention to the different
And on circle B. Now use your finger and trace each arc. Which circle has a longer arc? Circle A has a longer arc. But wait a minute. Don't both arcs measure 90 degrees? Why are their arcs different lengths? Maybe you're thinking, well, circle A is larger, so maybe it needs a larger arc. Or maybe you're thinking, you just don't know. Well, let's dig in and figure it out. How many total degrees in this circle?
Okay, who knows? If I go the whole way around a circle, how many degrees is that? Ilea? Ilea?
360 degrees.
Very good.
360 degrees. And how many total degrees in this circle?
How many total degrees in letter B, Ilea?
360 degrees.
Yep.
Also 360 degrees. If we divided each circle into 360 degrees, each arc length in circle A would be a little longer than the arc lengths in circle B. Here, I'm still measuring a quarter turn in each circle, and each arc is 1/4 of the total distance around the circle. Think of it like this. This string goes all the way around circle A. Watch. So it represents a 360 degree arc. And this string goes all the way around circle B. Watch. Again, representing a 360 degree arc. Now, if we take these strings and stretch them out to see how long they are, we can see how long the arc for circle A is. It's so long it goes off the screen. And here's the arc for circle B. Now, if I were to chop up each of these strings into 360 equal-sized pieces, which arc would have smaller pieces?
Which one, Tyler?
A.
Look how big A is. If we cut this string into 360 pieces and this string into 360 pieces, Sarah, which one would have smaller pieces?
B.
Right, because it's so much smaller.
Right, the arc for circle B would have smaller pieces. So 90 degrees is 1/4 of 360 degrees. I'm going to cut each string into 4 equal parts. So here is circle A's string, and I'll cut it into 4 equal parts. Here are the 4 equal parts from circle A's string and circle B's string now. Here are the 4 equal parts from circle B's string. Notice that one of the parts from circle A's string is the same length as the arc from circle A, and one of the parts from circle B's string is the same length as the arc from circle B. Now, which arc is longer? The arc from circle A is longer. So, does the length of an arc determine the measure of a given angle?
Does it matter, Nina? What do you think? Does the length of the arc determine its degree measure?
No.
No, because both of these measure 90, but you see the arc in letter A is much bigger. Who knows what determines the degree measure? Who can tell me what determines the degree measure? Anyone? The degree measure is how much an angle turns. So if we go from here to here, we're measuring how much this leg of the angle would need to move to match this one. So you're measuring the rotation or the turn.
Pause the video and explain what you're thinking. Hopefully you said no. We could have longer arcs or shorter arcs, but they could be measuring the same size angle. We just have to remember that no matter how big that arc is, it's still part of 360 degrees. We can have a really tiny circle with really short arcs, or a really big circle with really long arcs. But a right angle will still always measure 90 degrees. Let's place circle B on top of circle A now to prove that the length of an arc does not determine the degree measure. Look, those angles match. Way to go. Now let's take a look at angles C and D from your practice sheet. What kind of angles do you see? Right, they're both acute angles. And what do you notice about the arc length in each angle?
This is actually on page 28 in your student workbook. So we're looking at both of these angles. Hopefully you're noticing that both of these angles are smaller than a right angle. So they're both acute. Now we're going to practice measuring these.
Maybe you noticed that the arc length in angle C is longer than the arc length in angle D. It looks almost like angle C came from a larger circle than what angle D came from. Or maybe you were thinking that even though the arc lengths are different, it still looks like the angles might be the same size. Well, let's measure to see if each angle turns the same number of degrees.
So this is where you're going to need your protractor.
Do you remember what the tool is called that we use to measure angles? Right, it's a protractor. Take a look at this protractor. What do you notice about this protractor? Well, it certainly looks different than the protractor we used in the last lesson, right? The protractor that we used in our last lesson was shaped like a full circle, and it went all the way up to 360 degrees. This protractor looks like half of a circle, and it only goes up to 180 degrees. This protractor also has a straight edge. Great observations. Just like we measured angles with a circular protractor, we can measure angles with our 180-degree protractor. Now, protractors sometimes have two sets of numbers on them. We can see a set of numbers here on the outside and a set of numbers here on the inside. What do you notice about these two sets of numbers?
Okay, so if you look at these two sets of numbers, you should be noticing that the outside, the 0 starts to the left, and it counts the whole way to 180. On the inside over here, you start at 180 and it goes backwards to 0. When you're measuring something, what do you always want to start with, Brian?
Zero.
0. So this is really important. So we're going to talk about a couple different checkpoints, and starting with 0 is going to be one of them. So if your angle is pointing this way, you're going to use the bottom numbers. But if your angle is pointing this way, you would use the top numbers. So it really depends on how the angle is drawn, which numbers you're going to use, but you're always going to start with 0.
Did you notice that for the outside numbers, they start at 0 on this side and go around to 180 degrees over here? And for the numbers on the inside, they start at 0 over here, even though the 0 isn't labeled, and go around to 180 degrees over here. We determine which number to read based on the side of the angle that touches 0. So let's use our 180-degree protractor to measure angle C. To measure with this type of protractor, we first have to align this middle notch.
So that's your first checkpoint. You want to make sure now in your template, you don't have a middle notch. You have, it looks like an upside down T. That's the center of your protractor. The first checkpoint is making sure the center of this is lined up exactly with the vertex of the angle.
See that notch there? With the vertex of the angle. So here's the vertex of angle C where the two sides meet. And I'm going to align that with the notch in the center. There we go. And then we have to align the zero line or the baseline on the protractor with.
That's your second checkpoint. So you're going to make sure your vertex is lined up with the center, and then you want to look and see where the zero is. Right here, you want to make sure that the base of your angle is lined up exactly with the zero, or else your measurement's going to be off.
One of the sides of the angle. So I'm going to line that up. And then finally, we just read the number that aligns with the second side of the angle. Okay, so I'm going to go around second side of the angle. Here it is. Angle C measures 60 degrees. No, wait, 120 degrees. Which is it?
Which number should she use? Is the measure of this angle 60 degrees or 120 degrees? Go ahead, Brian.
60.
Why do you think it's 60?
Because the lower number is the degrees that is the degrees
No, because
that you follow.
120 is the degrees also. But why? So 60 is on the bottom. Why do you think we should use the bottom numbers for this angle? You're right, but just think, why are the bottom numbers the right numbers to use?
They go from 10 to
And her
360.
actually in the way, but you're correct, honey. Down here, 0. So you want to start with 0, not 180. There's another reason why you should know you're correct, is because if you look at this angle, it's an acute angle. So Brian, you know that an acute angle has to be smaller than what?
90 degrees.
Very good. And if it was 120, it wouldn't be acute. So that's another way to check yourself.
What do you think? Oh, right. This angle couldn't measure 120 degrees. It's an acute angle. That wouldn't make sense. So in choosing between these two numbers, we know angle C measures 60 degrees. We could also know, because remember, we count up from the side of the angle that touches 0. So we would count up from this side. If we were reading 120 degrees, then that would mean we counted backwards from 180. And that doesn't make sense. Now pause the video and use your protractor to measure angle D. Remember to align the vertex.
Yeah, I want you to go ahead and try that one. I want you to try measuring angle D with your protractor. And then we'll see if it matches. Remember, your checkpoint 1 is lining up the center of your protractor with the vertex. And since these are clear, make sure that your numbers are going the right direction, that's not backwards. Then you're going to make sure that the bottom, this part of your angle, is lined up with 0. Now let's check.
With that middle notch, align one of the sides of the angle with the 0 line or the baseline, and then read the number that the second side touches. Remember to think about if the angle measure that you got makes sense. When you get back, we'll discuss it. So what's the angle measure of angle D? It's 60 degrees. Wow, the angle measure for angle D is equal to angle C. The arc lengths are different, but the degrees are the same. So what do you think would happen if we put the angles on top of each other? Let's try it. I'm going to take this page protector and I'm going to trace over angle D and then put it on top of angle C. And let's see what happens. What do you notice? It matches up. The angles are the same size. Look at these different protractors. What do you notice? Well, this one is a 360-degree protractor, and these two are 180-degree protractors. They all have two sets of numbers, and they're all different sizes. Let's align our protractors using the center point like we did with our two circles at the beginning of the lesson. Do you see how all the protractors have different sized arcs? Some are smaller, some are larger, but they all measure the same degrees.
Okay, so now we're going to do some practice. So what I want you to do is I want you to turn to page 29 in your math books. And the page should look like this. I'm going to show you. We're going to do some practice measuring. So you really want to make sure you have a nice hard surface to write on, because if you try doing this on your lap, probably going to be wrong. So this is a couple tips that I have. The first thing is, with your pencil or with a marker, I like to darken in my vertex. So when I take my protractor, and this is the one that we have because right here is where we're lining it up, I'm going to line up that with my vertex. Now my vertex is lined up perfectly, but as you can see, and I'm actually going to make my whole angle green so it's easier to see through all those lines. But if I have my vertex lined up, my bottom of my angle is not lined up with 0. So my answer is going to be wrong. So I'm going to turn, still trying to keep my vertex lined up, so that right now you can see my bottom is lined up perfectly with 0, and my vertex is lined up with the center of my protractor. So Ilea, when I look at this angle, I'm measuring, I'm going to darken my arc in, from the bottom of the angle to the top. So since we're starting at the bottom, am I going to be using the top row of numbers or the bottom row?
The bottom.
Because it's 0. Very good. So if I travel up my protractor and I see this is where the angle side is short. So sometimes you can extend that using a straight edge. And I'm just going to follow this with my pencil, and I'm going to see that this measures how many degrees, Ilea?
40.
40 degrees. So right here, I'm going to write 40 degrees. Okay, let's go over to letter B. First thing I'm going to do is draw a point on my vertex. Okay, let's see who remembers. Brian, what's my first checkpoint? What do I want to do first?
Line the protractor up with the angle.
With the vertex. Very good. Okay, so
Vertex.
here's the center of my protractor. I line it up. Now what do I do, Olivia?
You trace or you look at the top of the angle.
Hold on,
And
before I can look anywhere yet, my first check is to make sure that the vertex is lined up. What do I have to check next? What do we always start measuring with? What number?
0.
0. And you see this angle's pointing towards the left. I'm going to go over it just so I can see it better. So this time I have my vertex lined up, but I'm not going to use this side because my angle's not pointing that way. But if look here, I have my vertex lined up, but the bottom of my angle is hanging out down below. So I'm going to turn till it's perfect. Now I'm measuring from here to here. So Olivia, which set of numbers will I be using? The bottom or the top?
The bottom.
Why is that?
The bottom has 0 and the top doesn't.
Very good though. Well, hold on. Which numbers am I using? The bottom or the top?
The bottom.
What does the
Or
bottom
top.
start? The top, because it starts with 0. So Olivia, if I measure from 0, let me make sure you touch it a little bit, it messes the whole thing up. So now I'm going from 0 up to where this other arm is. So I'm using my top numbers. So now you can see I'm traveling up, and it's bigger than 30, but it's not quite to 40. So this angle measures about how much?
About 40 or
It's
30.
Here's the 40 line. It's long, it's past the 30, but it's not yet quite to the 40. So what does it look to be close to? Like
30,
go ahead.
35.
Yeah, sure, about 35, because when you can see white in between, it's not close enough to say about 30 or about 40. So we have to count these itty bitty tick marks. So we're going to say this is about, I think you said 36 or 35. I would take either of those answers to be correct because those degrees are so tiny. So either of those would work. Soren, are you following along? All right, now we're going to go to C. Tyler, do you have your protractor? Okay, we're going to move on to C. So the first thing, that's not a protractor. That has no numbers on it. You made that. That's a right angle detector. If you don't have this tool, you need to get your template out of your toolkit. You can't measure with a homemade device. I'm going to plot my vertex. Now I'm going to take my right angle detector and put it on. I'm sorry, they got me confused. I'm taking my protractor, line up my vertex. Oh, I'm going to trace this so I can see better. Line up my 0 with the base. Sarah, what does letter C measure and how do you know?
90 degrees because
Am I using the bottom or top numbers here?
we're using the bottom
The bottom.
numbers.
Here's 0. We travel the whole way to the other leg and it's at 90 degrees. Very good. Tyler, did you go get your protractor? Okay, you're not learning anything right now from not having your tools. Brian will be back to school tomorrow, so I'll be able to watch him measure. I won't see you, so you have to have your tools ready for class. Go get it. This whole lesson is about using this, and if you don't have it, you're not getting much out of this. All right, Soren, you're going to walk me through letter D. So I'm going to move my book, turn it to make it easier for me because I can do that. Soren, I'm going to make my point here, my vertex, and I'm going to outline these so I can see better. What do I do first?
You get out your protractor.
Got it? Now
You
what?
place it on the angle.
Okay.
No. The
Help me. What do I line up?
point at, well, the right angle at the bottom should be put over the dot.
Okay, so I want my center of my protractor on my vertex. Okay, now what?
And then you look for the angle.
Okay, well, first, my second step is I have to make sure my bottom of my angle is lined up with 0. And it's not right now, so I'm going to have to turn. Now we're with 0. Now, Soren,
Yeah.
am I using the bottom numbers or the top numbers?
The top numbers.
Why is that?
Because the point that is going left is like the main line.
And we need to start with what number when we measure?
0.
Yep. So Soren, if you follow my angle the whole way from 0 to where my other side is, what does angle D measure?
Angle D measures 90 degrees.
Very good. 90 degrees. Okay, so far, I'm going to close this so I can see your faces. Do you have any questions? Anything that's confusing? All right, I want you to turn to page 30. We're going to do a couple more practice. Okay, let's go to letter F. So for letter F, I'm going to darken in my vertex, and I'm just going to outline. Now, if you have a pencil, I wouldn't suggest doing this. I'm just doing it because I have green, and it makes the sides of the angles stick out for me. And I also know I'm measuring from here to here. Okay, so Peyton, tell me what to do. No volume, Peyton. No volume, Peyton. Try again, honey. Try again, honey. There you go, Tyler. That's what you're gonna have to use the bottom one since you didn't get this one. All right, Sarah, why don't you help us out while we're waiting for Peyton to get his test out his volume. What do I do first?
Okay, so you put the point where the vertex, you put the vertex over the point.
Okay.
So then wait a second. Like
Okay,
maybe
so
rotate
the
your
center of my vertex is on the point. Now what?
like maybe rotate your page.
I'm gonna have to turn this so that this leg is on 0.
Yeah.
So I'm gonna rotate, rotate, rotate. Now it's matched up with 0. Am I using the bottom or top numbers? Look, here's the leg. It's coming out here. Am I going to use 180 on the bottom or 0 on the top? 0. So you always start with 0. Now I'm going to travel the whole way around here to about here. So I travel from 0 over to 90. Now I'm in the hundreds, 110, 120, 130, 140. It goes past 150, but it's not yet to 160. So what would this measure? About what?
Around 155.
Sure. 155 degrees. And make sure your degree symbol is nice and small so you don't mistake it for a 0. All right, Aaliyah, we're going to try one more, and you're going to do this one for us. Why don't you do letter E? So I'll zoom in so you can see better. Make my vertex for you green so you can see it better. What do I do first, Aaliyah?
So you take your protractor and you put the vertex like on top of the point.
Okay.
But then you have to like rotate it so it like looks like straight, I think.
What's that?
And you have to like rotate it to
Yeah,
make
I got to turn this around because I need to get this bottom leg on a 0. So I'm going to turn, and then I still got to make sure I could keep turning, but look at my vertex. The center of my protractor moved off. So I got to make sure to take it back. Almost like when you cross the street. Look right, look left, double check left again, look right. So now I have my center lined up and I have the bottom of my angle lined up with 0.
now you like start at 0 and you like measure where the line is, but it's not on 40 and it's not on 30, so you have to like measure the tick marks.
Right, so we go past 30. It's not yet to 40. So what do you think? It's really close to 40 though. So we could say this is about what?
47.
Now 47 is the whole way up here.
37.
Yeah, I agree. About 37. There we go. Okay, so stop sharing. So I want you to go ahead, and if I were you, I would try some of these and see how you're doing, because tomorrow you're going to have to start drawing some of these. So we got to be pretty comfortable with using this. When you get on your Schoology page, there's also a it's kind of like a game, but it's practice. Since I can't actually be with you, and like in school I could kind of walk around and check everyone's protractor. Since I can't physically do that with you, you have an activity. It's your last thing on Schoology for today, so that you can practice using a protractor. So Brian, you can get on there, okay? Okay. All right, anyone have any questions? Okay, thank you. I'll see you guys tomorrow.